what's going on? Let's see what is this. Is this gonna be torture? I have no idea. Let's reshape the matrix and so here you're reshaping the matrix. I have one row and four columns. One, two, three, four. Okay, you reshape the matrix. Wait, what? In the same row to original as they were. Otherwise, I'll put the original if it's not possible. So you still use the row traversing to fill in. I don't know, but this one seems easy. I mean, I think I'm right in saying that all you gotta do is create this matrix. Zero, zero. Basically, if doesn't do anything. Oh, here we go. Okay. If r time if r times c doesn't equal r times c, return the original matrix because then it's impossible. Otherwise, it should be impossible. Otherwise, it should be possible. Yeah. There's another way to do this. One way to do it, you can fill in a vector like this. You can fill in this vector. So while this is an easy problem, probably there's a more interesting way to solve it. I would guess. Let's see. So I didn't really explain this, but I mean here I'm using an array, so that's pretty self-explanatory. It's an array that's going to have the appropriate size, which is r times c. This check here, I think I should do earlier, and then hold on. I'm not gonna. I think this is. Submit this. I think this is about it though. do that, and then searches. And then let's go over the theory a little bit. See if we can have any interesting thoughts, which I do not know yet. Okay, so give me the thing. Well, it's easy, so I don't know, but it doesn't matter. It's easy. There could be a way to make it more interesting. Okay, I'll give it a thumbs up. Whoa, what the heck? And then retrieve last submitted, which is this. Oh, this is complaining because you haven't defined this yet. Okay, so let's submit this. And then let's discuss. And then I'm gonna go into this a little bit. Okay, so what we're doing here is we compute the row, the number of rows, the number of columns in the original matrix that we're given. And we really want to check for this matrix that we're filling out, we know there's going to be R times C elements in it, and we know there's how many elements we have originally. So do we have enough elements in the original matrix to fill in the new matrix? If not, we want to return the original matrix. Then here we create a vector that's going to be able to contain all the elements that we need. This could be, doesn't matter what R I use here. So it's just a 1D array for storing elements in order, right? Um, and then here we have this will be the matrix that is returned. Um, yeah, so oh, and this is a double check. We don't need that. And then in K initializes the K. K is basically going to be the index for this array, which we increment every time we set it equal to an element. Here we're just iterating through everything in here, and then we just start over and we're going to fill it in with our new matrix. So this problem is creating a new copy of a new matrix, but it's doing more than that. It's also creating this copy. This we probably could get rid of if we just do something like this. So let's get rid of the 1D array, because the reason why we probably won't need it is instead of doing K, we could just do row and column for this new matrix, and then iterate through, and then do m row column, and then what we could do here is, I don't know if you can do mod like that, but then we need to update, and we won't need this, and we needed to update the row and the column after each instance. So we add one, and we need to mod it with R, because the reason why is because R is the number of rows that we have. So once row is equal to R, it'll wrap around and it'll start back over at the 0th index for a row. So in that sense, you'll keep iterating. This is actually not going to work though, because you're supposed to iterate through the columns before you iterate through the rows. So actually, let's see, if you use C++, if C, sorry, when you do column plus plus, if column is equal to C, then you want to do row plus plus, and then um, mod this, and then mod this. So we can use modding to kind of keep the elements in the sequence, or so that they wrap around. So like if we look at the values for a column, because a column is what changes a lot, it's 1, 2, 3, and maybe C is equal to 3. So it's 0, 1, 2, and then when it hits 3. When it hits 3, we can't actually have a column that is 3 because we can only have indices 0, 1, and 2. So when we hit 3, it actually goes back to 0, and it repeats the same thing. But also, when it does this, 0, 1, 2, if we look at the row, this is what column is equal to. The row is equal to 0, 0, 0, then we increment it, and so on. I don't think I need to mod the row, because the row will never exceed. So the column is the one that will exceed, and when it exceeds, you just do this, and you mod it. That's using mod. Run that, submit it. And another thought here is really, why does it matter the mod it? Just set it to 0. I don't know, because you don't even need to use that concept of modulus. Problem can be solved without modulus. Now you got the problem down to basically for loops, knowing what a matrix is, iterating over a matrix. I think that's about it actually. Okay, can we do this in place? What would that take? So we can't really do it in place. We have to create a new matrix. And the reason why we have to create a new matrix is because, like, how else are you going to reform this matrix? You have to resize this current matrix, which I guess you could do that. That's reasonable for sure. Actually, this is true. You could use your original matrix. So let's try that. There's a function called resize. So we can resize the matrix. Oh, but can R decrease? Yeah, R can decrease. So we can resize the matrix, and then for each of these, we can resize the C. So we can resize, and then let's get rid of this matrix. And then what you want to do is, oh, but if you resize, you could lose some elements, right? So this isn't gonna work. Yeah, you could lose some values in the original matrix. So no, I think this is the way to go. I'll go to discussion to see if there is a way to do it in place. But yeah, I think that's good. I don't know. There's not that much to go into this problem. It's rated easy. It's just a matrix problem. I guess it's not that interesting.